Quick, graph y equals the cosine of the quantity 1/2 times x by hand 2 different ways. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed. And as always, press pause as needed anytime during this video. The first way is with the cosine dance. Recall the graph of one period or one wave of the cosine function. And note the 5 key points of interest. These key points are affected by the parameters in the equation. In this case, the only parameter is inside the argument, 1/2 times x. The coefficient of x, which we use b, is equal to 1/2 inside the parentheses. This affects the width of the period inversely. The horizontal dilation factor is the reciprocal of that 1/2, which would be 2. The period of the cosine function is normally 2 pi. For this function, the period is going to be 2 times that 2 pi, which is 4 pi. Pause is needed. Resume when ready. So the period is 4 pi. That means we need to use a different scale along the x-axis. We suggest marking off every pi along the x-axis. Pause to do that. Oh, notice that the units are not drawn to scale. The initial point on the cosine is a maximum at 0, 1. The point is unaffected by this factor of 1/2 times x, so that will still start at 0, 1. The end of the period is also at a max at 2 pi, 1. For this, it will end at 4 pi, 1, because the period is 4 pi. Halfway between those 2 points is a minimum, normally at pi, -1, but in this case, halfway is 2 pi, -1. Halfway between each of those 2 points are points of inflection. So halfway here would be at pi 0, and halfway here would be at 3 pi 0. Pause is needed. Connect the points as a cosine wave, concave down, concave up, concave down. And this is one period of the cosine wave, and we'd like to duplicate that in the negative direction. So we're going to start with this maximum point and go back a period, which is 4 pi. So -4 pi, 1. The next is from this point of inflection back a period, from the minimum back a period, and from this point of inflection back a period, which is 4 pi from there. Connect the points as a cosine wave, frown, smile, frown, and compare it to the parent function in blue. So the blue function's period is 2 pi. For the green function, we only get half the period in that same distance there. So half the period of the green function is the same as the parent function in blue. And pause is needed. Now generalization, the period of a cosine wave is normally 2 pi. But what about the period of an equation of the form y equals the cosine of the quantity, some constant b times x? Since b affects the period inversely, the normal period is multiplied by the reciprocal of b, and that is the period of y equals cosine of the quantity b times x is 1/b times 2 pi, which is the fraction 2 pi divided by b. So this is a big deal. We suggest you write it down to remember it. Pause to do that. Let's see if you can apply this generalization here. Pause to answer these 3 questions. Resume when you're ready. So the first one, the coefficient is 4. 2 pi divided by 4 will become pi over 2. 2 pi divided by 5, 2/5 pi. And the last one, dividing by a third, is the same as multiplying by 3. So 2 pi times 3 is 6 pi. Pause is needed. 2 pi times 3 is 6 pi. 2 pi divided by 5 is 2/5 pi. 2 pi divided by 5 is 2/5 pi. So 2 pi times 3 is 6 pi. 2 pi times 3 is 6 pi. 2 pi divided by 5 is 2/5 pi. Pause is needed. Connect the points as a cosine wave, concave down, concave up, concave down. And this is a big deal. We suggest you write it down to remember it. Pause to do that. So the second way to graph this was using a table. Go ahead and complete the table. Pause is needed. And those are our unit circle values along the axes. Create a second table, and we realize that the coefficient of x, which is 1/2, that's inside the parentheses, inside the argument, affects the width or the period of the graph inversely. So we're going to have to multiply each x value by the reciprocal of 1/2, which is 2. We're going to need to change the units on the horizontal axis because of this 2. So we're going to double the period and mark off every pi. Pause is needed to do your own. And this is what we came up with. Multiply each x value by 2, so 0 times 2 is 0, but the y values there are no parameters to affect the y values, so the y values stay the same. So we'll start with 0, 1. Pi over 2 times 2 is pi. Again, the y coordinates stay the same, pi 0. Pi times 2 is 2 pi, comma -1. 3 pi over 2 times 2 is 3 pi, comma 0. And doubling 2 pi, we get 4 pi, comma 1, a maximum. Pause is needed. Connect the points as a cosine wave, concave down, concave up, concave down. This is one period of the wave. We'd like you to plot another one to the left by backing each point of the period, which is 2 pi. And we can compare that to the blue parent function. Now you try one. Graph y equals the cosine of the quantity 1/3 times x using either method or both for the practice. Also, tell us what the period is. So pause to do this, resume when you're ready. So the period is 2 pi divided by 1/3, which is 6 pi. So we get one complete wave there. This is going in the negative direction.